Welcome to today's deep dive, everyone. We're going to be talking about a tiny terror that causes huge headaches for soybean farmers, the soybean aphid.
Yeah, they might be practically invisible to the naked eye, but these little guys can have a devastating effect on yields.
And to help us unpack all of this, we have an expert with us today.
It's great to be here.
So to kick things off, let's talk about Pharmanaut. This is an agricultural technology company that is really stepping up to the plate to help farmers protect their soybean crops and maximize their yields. How are they doing that?
Well, they're giving farmers the information they need to make really informed decisions about how to manage these pests.
That's fantastic. Now, just to make sure everyone's on the same page, we're talking about those tiny little bugs, sometimes green, that you might see on the undersides of leaves. They're not all bad, of course, but some of them are soybean aphids.
Right, and these are the ones that can really do some serious damage.
So let's break it down. What exactly is a soybean aphid?
Well, it's a pear-shaped insect that's usually kind of a light green or a pale yellow, and they're really tiny, only about 1/116th of an inch long.
Wow, that's incredibly small.
It is, but the problem is that they reproduce so quickly.
So it's a tiny but mighty situation.
Exactly.
What makes their reproduction so difficult for farmers to manage?
Well, they can have something like 18 generations in a single growing season.
18.
18 generations in just a few short months.
Wow, that's mind-boggling. No wonder they can get out of control so quickly. How do they actually damage the plants?
Well, what they do is they feed on the sap in the leaves and the stems, and this weakens the plant and it reduces its ability to photosynthesize.
Ah, so they're literally sucking the life out of the plants.
Yeah, pretty much. And this can lead to stunted growth and yellowing leaves, and ultimately it reduces the number of pods that the plant can produce.
So less yield.
Right. And then to make matters worse, they don't just cause this direct damage.
What else do they do?
They can also spread viral diseases.
Oh, no.
Yeah, like the soybean mosaic virus.
And that can hurt yields even more.
Exactly. And on top of that, they secrete a sticky substance called honeydew.
Honeydew?
Yeah, I know. It sounds kind of nice, but it's actually not good at all.
Why is that?
Well, because it makes it really easy for the sooty mold to grow, and that blocks sunlight, which hinders photosynthesis even more.
It's like a double whammy for the plants.
It is.
Ugh, sooty mold. That just sounds unpleasant.
Yeah.
So we've got these aphids that are reproducing at an alarming rate. They're sucking the life out of the plants. They're spreading diseases. They're creating this environment where this mold can grow. What can farmers do?
The key is early detection. The sooner they know they have a problem, the sooner they can take action.
Okay. So how do they know if they have a problem?
Scouting. That's really important.
Scouting. How often do they need to do that?
Well, ideally, they should start pretty early in the growing season, maybe around the V1 stage when you start to see those first trifoliates.
Yeah.
And then they should just keep scouting regularly, especially during those periods when the plants are growing really quickly.
I can imagine walking through those fields row by row looking for these tiny bugs. It's got to be pretty time-consuming.
It can be. Yeah, especially in a large farm. Luckily, we've come a long way from just using handheld magnifiers.
What are some of the other tools that are available now?
There are smartphone apps that can help farmers track what they're seeing, and there are even more advanced technologies like drones and satellites.
And speaking of satellites, this is where Pharmanaut really comes in, right?
Exactly. They have this amazing satellite-based detection system.
How does it work? I mean, are the satellites actually looking for the aphids themselves?
Not quite. They capture these images of the fields and then they analyze the light that's being reflected by the plants.
Interesting. So how does that tell them anything about the aphids?
Well, certain wavelengths of light can indicate that a plant is under stress, and this can happen even before you can see any visible symptoms.
So it's like the plants are sending out an SOS signal that only the satellites can see.
It's kind of like that.
That's amazing.
It is, and this early warning gives farmers a huge advantage. They can deal with a potential infestation before it has a chance to really take hold.
Wow. So instead of reacting to a problem, they can be proactive. That's got to save a lot of headaches.
Definitely. And a lot of crops.
So it sounds like Pharmanaut's system can do a lot more than just detect aphids.
That's right. It also provides historical data analysis, which allows farmers to see patterns in their fields and identify areas that might be at higher risk for infestation.
So it's like having a crystal ball for aphid outbreaks.
It's kind of like that, yeah.
But even with the best detection systems in the world, knowing when to actually take action is critical, and that's where those economic thresholds come into play.
Yes, exactly. So those help farmers figure out how to balance the cost of treating for aphids against the potential yield loss if they don't treat.
Right, because treating for aphids involves costs.
Yeah, of course.
Yeah.
And farmers need to weigh those costs against the potential benefit.
What's the typical economic threshold for soybean aphids?
It's usually around 250 aphids per plant, with about 80% of the plants being infested. But that can vary depending on several factors.
What kind of factors?
Things like the growth stage of the soybeans, how much they're selling for the cost of the control methods that are available. Even the weather can play a role.
So there's no magic number.
Right. Every farm is different. And Farminaut can help farmers determine what the appropriate economic threshold is for their specific operation.
That's really helpful. Okay, so we've talked about scouting and early detection, but what about actually managing these infestations? Let's dive into integrated pest management.
IPM.
Yeah.
What is that?
Well, it's basically a much more sustainable approach than just reaching for the strongest pesticide. It's about combining different methods to control the aphid population, but in a way that minimizes the impact on the environment and on those beneficial insects.
Okay, so break that down for me. What are some of the key elements of this approach? Well, first you have what we call cultural control methods. These are things that focus on making the environment less hospitable to the aphids in the first place. Things like crop rotation planting at different times, using resistant varieties, cleaning up the fields to remove any potential overwintering sites.
So just making it harder for the aphids to get established.
Exactly. And then there's biological control. This is all about harnessing the power of nature.
Okay.
So you want to encourage the natural enemies of aphids,
Right.
like wood-eating beetles and lacewings and those parasitic wasps that prey on aphids.
Nature's own pest control squad.
I like that. And of course, there's also chemical control, which involves using insecticides, but in an IPM strategy, you really only want to use insecticides as a last resort.
When the aphid population gets above that economic threshold we were talking about.
Right. And even then, you want to choose insecticides that are going to target the aphids specifically and minimize the harm to those beneficial insects.
You're not wiping out the good guys along with the bad guys.
Exactly. We want to keep those predators around to help us out.
Makes sense. Is there anything else that's important when it comes to chemical control?
Yeah, resistance management. Meaning we don't want the aphids to become immune to the insecticides.
Oh, right.
So you need to rotate the different types of insecticides that you use to help prevent resistance.
Interesting. Okay. So we've got cultural control, biological control, and chemical control. Are there any other strategies that farmers can use?
There's also something called host plant resistance.
Host plant resistance. What is that?
It's basically using soybean varieties that have some built-in resistance to aphids.
Okay, so certain types of soybeans are naturally better at fending off these bugs.
That's right. There are certain genes like RAG1 and RAG2 that can make the plants resistant to some aphid biotypes.
That's amazing. It's like giving the plants their own suit of armor.
It's kind of like that, yeah.
Yeah.
And it can be a really effective long-term strategy, but the aphids can evolve.
Oh, right. Of course. They're always one step ahead.
That's why we need to keep doing research and keep breeding new varieties to stay ahead of the game.
Okay, so it sounds like there's a lot that farmers can do. But what about the future? What's on the horizon when it comes to aphid management? What are some of the technologies that could change the game?
Well, there are some really exciting things happening. One of the big ones is gene editing.
Gene editing. I've heard about that. Sounds pretty futuristic.
It is. It's basically a way for scientists to make really precise changes to the DNA of plants. And they can do this to give them very specific traits.
So we're talking about creating plants that are genetically engineered to resist aphids.
That's the idea. And this could potentially lead to soybean varieties that are resistant to the aphid biotypes that we see today, and also to the ones that might evolve in the future.
So a more permanent solution.
Hopefully. What else is coming down the pipeline? Well, we've talked about big data and predictive modeling.
Right, using all that data from sensors and weather stations and satellites to forecast outbreaks.
Exactly. And all of that is just going to get more and more sophisticated in the years to come. We'll be able to predict outbreaks with incredible accuracy.
That's pretty amazing. And then there's nanotechnology.
Yes, nanotechnology. That has a ton of potential for pest control, too.
I have to admit, I don't really understand how that works. Can you give me an example?
Sure. One of the things researchers are looking into is using nanoparticles to deliver pesticides in a really targeted way. So these nanoparticles could be designed to attach specifically to aphids.
So it's like a guided missile system for pesticides.
Pretty much, yeah. And then they're also developing nanosensors that could be embedded in the plants themselves.
What would those do?
They could detect the presence of aphids or even the chemicals that aphids release long before there are any visible signs of an infestation.
So it's like an early warning system built right into the plants.
Exactly.
That's wild. What about IPM 2.0? You mentioned that earlier. What is that all about?
It's kind of like the next generation of integrated pest management. It's a much more holistic approach. It's about taking the entire agro-ecosystem into account.
So not just focusing on the aphids themselves, but looking at the bigger picture.
Exactly. You have to understand how everything interacts, the plants, the pests, the beneficial insects, the soil, the weather, even human practices.
So instead of just trying to kill all the bad bugs, we're trying to create a more balanced and resilient ecosystem.
Exactly. IPM 2.0 is all about preventative measures and cultural practices and biological control. And then you only use chemical treatments when absolutely necessary.
And of course, all of this relies heavily on those advanced technologies we've been talking about.
Right, things like real-time monitoring and predictive modeling and AI-powered decision-making tools.
So it's like we're combining the best of science and technology and a deep understanding of nature.
Exactly. And it's really exciting to see how all of this is coming together.
Well said. It sounds like there's a lot to be optimistic about.
Definitely.
All right. So we've covered a lot of ground today. You've talked about the challenges of soybean aphid management, the importance of early detection, the power of integrated pest management, and some of the amazing technologies that are on the horizon.
It's a fascinating topic.
It is. Now, before we move on to part 2, where we'll hear from some farmers who are on the front lines of this battle, I want to leave our listeners with a quick recap of the key takeaways.
Great idea.
First and foremost, early detection is crucial. Regular scouting combined with these amazing monitoring technologies, like those offered by Pharmanaut, can give farmers a real edge in this fight.
And when it comes to deciding whether to treat or not, remember those economic thresholds.
Right, weigh the potential losses against the cost of treatment.
Exactly. Make informed decisions to protect both your crops and your bottom line.
And don't forget about the power of integrated pest management.
IPM. It's such a valuable tool for managing aphids sustainably. It helps you stay one step ahead of the game while minimizing your impact on the environment.
Couldn't have said it better myself.
Yeah.
Now, as technology continues to advance, the future of soybean aphid management is looking brighter than ever.
Absolutely.
With things like gene editing and predictive modeling and nanotechnology and AI-powered decision-making tools, we are entering a new era of precision and efficiency in pest control.
It's a very exciting time to be involved in agriculture.
Absolutely. So to wrap up this part of our deep dive, I have a question for our listeners. What do you think the future holds for managing these pests?
Yeah. What role will technology play? What challenges do you foresee?
We'd love to hear your thoughts. And as always, remember, Pharmanaut is dedicated to empowering farmers with the tools and knowledge they need to protect their crops and maximize their yields. Be sure to check them out.
They're a great resource.
All right, we'll be back soon with part 2, where we'll hear from some farmers who are using all of this knowledge and technology to combat these tiny but mighty pests. Stay tuned.
Looking forward to it. Welcome back to our deep dive into the world of soybean aphid management. We're going to shift gears a bit now and hear from some farmers who are actually out there in the fields dealing with these pests day in and day out.
I'm excited to hear about their experiences. And what are some of the specific challenges they face? And how are they using the knowledge and the technologies we've been talking about to overcome those challenges?
Yeah. Let's start with a farmer in the Midwest. We'll call him Bob.
Okay.
Bob's been battling soybean aphids for several seasons now. He's tried a lot of different control methods, but he's really looking for something that's more efficient and more sustainable. And he decided to give Pharmanaut's satellite-based monitoring system a try.
Interesting. What did he think?
He was a little skeptical at first. He wasn't sure about relying on satellites to monitor his crops, but he was really impressed with how accurate the data was and how quickly he was able to get that information.
So instead of spending hours walking through his fields scouting for these tiny aphids, he could get a bird's eye view of his entire operation right from his computer or his smartphone.
Exactly. And that allowed him to intervene much earlier. The system can detect stress in the plants before you can even see any visible symptoms.
So he was able to treat those areas before the aphids really had a chance to take hold.
Right, which meant he could use less insecticide overall.
Saving him money and reducing the impact on the environment.
Exactly, and that's something we hear a lot from farmers who are using this technology. They're able to make more informed decisions about when and where to treat, which means they're using fewer chemicals, and that's better for everyone.
All right, so we've got Bob in the Midwest. Let's hop across the globe now and meet Maria, a soybean farmer in Brazil.
Maria,
Maria faces a different set of challenges. She doesn't have access to all of the fancy technology that Bob has, and she's also dealing with aphid biotypes that are resistant to some of the commonly used insecticides.
Right. She's been focusing on really optimizing those cultural and biological control methods that we talked about.
So things like adjusting the planting dates to try to avoid those peak aphid populations.
Exactly. And she's been working with some local researchers to find those native beneficial insects that are effective against the specific aphid biotypes that she's dealing with.
It's amazing how farmers around the world are finding ways to adapt and innovate.
It really is.
Yeah.
And it just highlights how important it is to share information and collaborate. You know, farmers can learn so much from each other, and organizations like Farminaut are really helping to facilitate that exchange.
That's great. Now, speaking of Farminaut, I was reading about a project they're involved in that's using a network of sensors and weather stations to track aphid populations and predict outbreaks.
Oh, yeah. That's a really cool project. It's based in Minnesota.
What's the goal of that project?
Well, it's all about developing a real-time early warning system for aphid outbreaks.
So they're combining data from all these sensors and weather stations and even satellites.
Right. And then they're feeding all of that data into these powerful algorithms and machine learning models.
And what does that allow them to do?
It allows them to create these really accurate forecasts of when and where aphid outbreaks are likely to occur.
It's like having a crystal ball for aphids.
Pretty much.
Mhm.
And that gives farmers a huge advantage because they can be proactive. You know, they can take steps to protect their crops before an infestation even happens.
That's incredible. So it sounds like the future of soybean aphid management is looking pretty bright.
It is. There are a lot of reasons to be optimistic, but we also need to remember that this is an ongoing battle. You know, the aphids are constantly evolving, and we need to be just as adaptable and innovative in our approach to managing them.
You're absolutely right. We can't get complacent. So for our listeners out there who maybe aren't farmers themselves, is there anything they can do to help in this fight against soybean aphids?
Absolutely. There are actually a lot of ways to get involved. One of the most important things is to support research. You know, a lot of universities and agricultural research institutions are doing really amazing work in this area, and they often rely on public funding to support those efforts.
So donating to those organizations or advocating for more funding for agricultural research.
Exactly. Even small contributions can make a big difference.
What else can people do?
Well, you can also support your local farmers, you know, especially the ones who are using sustainable farming practices, including integrated pest management.
So buy their products at farmers markets or just spread the word about the work that they're doing.
Exactly. It all makes a difference. And I think it's important to remember that even small actions can have a big impact. You know, just by staying informed about the challenges that farmers are facing and advocating for solutions, we can all play a role in creating a more sustainable and food-secure future.
Well said. And we're back for the final part of our deep dive into the world of soybean aphid management. We've talked about the challenges farmers face, the importance of early detection, the power of integrated pest management, and now it's time to really let our imaginations run wild.
It is time to look at the technologies that are on the horizon that could revolutionize how we deal with these pests.
Sci-fi stuff.
Yeah.
Exactly.
All right, so what's first on our futuristic adventure?
Well, let's start with gene editing. This is a technology that's been making a lot of headlines lately.
I've heard about gene editing, but I don't really understand how it works.
Okay, so basically it's a tool that allows scientists to make very precise changes to the DNA of plants. So we're talking about genetically modified organisms, GMOs.
Well, yeah, you can think of it that way. But it's much more targeted and precise than the older methods of genetic modification.
Okay, so what does that mean for soybean aphids?
Well, it means that we could potentially engineer soybean plants that are resistant to those aphids.
Aphid-proof soybeans.
That's the goal.
So how would that work?
Well, scientists could identify the genes that make some soybean plants naturally resistant to aphids.
Okay.
And then they could use gene editing to insert those genes into other varieties that aren't naturally resistant.
So you're basically giving those plants the genetic tools they need to fight off the aphids.
Exactly. And the really exciting thing is that we could potentially create soybeans that are resistant to the aphid biotypes we have today, A and D, the ones that might evolve in the future.
That's amazing. So we could be one step ahead of those pesky aphids.
We could, and that would be a huge win for farmers.
Absolutely. What other futuristic technologies are we looking at?
Well, we've already talked about big data and predictive modeling, and those fields are just going to become more and more powerful and sophisticated in the years to come.
So we're talking about using all that data from sensors and weather stations and satellites to predict aphid outbreaks even more accurately.
Exactly. Imagine getting an alert on your phone that says, Warning aphid outbreak predicted in Sector 5 next week.
Wow, that's incredible. So you know exactly where to focus your efforts.
You would. You could deploy beneficial insects. You could apply a targeted insecticide treatment. You could make those decisions before the aphids even had a chance to do any real damage.
That's the kind of precision agriculture that we need.
It is. What else is coming? Nanotechnology.
Nanotechnology. Now that one really sounds like science fiction.
I know, right? But it's got some amazing potential for pest control.
Okay, I'm going to need an example here because I have no idea how you would use nanotechnology to fight aphids.
Okay. Well, one idea is to use nanoparticles to deliver pesticides.
Nanoparticles.
Yeah.
We're talking about tiny, tiny particles.
It's like incredibly tiny. And these particles could be designed to attach specifically to aphids.
Okay.
So they would deliver the pesticide directly to the targets and they wouldn't harm any other organisms.
So it's like a guided missile for pesticide.
It's a great analogy. And then there's also research into using nanosensors.
Nanosensors, what are those?
They're tiny sensors that could be embedded in the plants themselves or placed in the fields.
And what would they do?
They could detect the presence of aphids long before you could see any visible signs of an infestation.
So it's like an aphid alarm system.
Pretty much. And
Good.
that would give farmers even more time to take action.
That's amazing.
Okay.
So we've got gene editing, big data, nanotechnology. You mentioned something earlier about IPM 2.0. What's that all about?
Ah, yes. IPM 2.0. It's kind of like the next generation of integrated pest management. It takes a much more holistic approach. It's about looking at the entire agroecosystem and all the complex interactions that are happening within that system.
So it's not just about killing the aphids. It's about creating a more balanced and healthy ecosystem.
Exactly. It's about prevention. It's about using cultural practices. It's about harnessing the power of nature.
And only using those chemical treatments as a last resort.
Right. And of course, it relies heavily on all of these advanced technologies that we've been talking about.
The real-time monitoring, the predictive modeling, the AI-powered decision-making tools.
It's all coming together. It's an incredibly exciting time to be involved in agriculture.
It really does sound like we're on the cusp of a new era of sustainability and innovation.
We are.
That's about all the time we have for today. But before we go, I want to thank our listeners for joining us on this deep dive into the world of soybean aphid management.
It's been a pleasure.
It has. And remember, knowledge is power. The more we understand about the challenges facing agriculture and the solutions that are being developed, the better equipped we'll be to create a more food-secure and sustainable future for everyone.
So keep learning, keep exploring, and keep asking those questions.
Absolutely. And on that note, thanks for listening, and we'll see you next time.